What we have in front of us here today is an Acer Aspire 5742 laptop, and this laptop was sent in for repair. The customer has stated that the problem he was experiencing was that the laptop would hang on the first boot screen, so he was not able to use the laptop at all. Now, what he did mention was, after a while, he realized that if he removed the battery, then the laptop would proceed to start up, and he was able to use it like that for a while. But eventually that packed in as well, and the laptop would not start at all. So this came in for repair. The first thing I did was I checked the voltage output from the charge adapter, and this was showing as 19 volts, so I could confirm that there was no issue with the charge adapter. The second thing I had to do was I had to confirm that the socket where the power comes in onto the laptop was functioning correctly, and power was coming from that socket into the motherboard. So I needed to check that. I've taken all this one apart, and I removed the keyboard and I took the motherboard out and all the other components. And if you have a look here, this here is the cable that comes. It goes from here and it follows round into the charge port. Okay, so I had the adapter connected and I was able to follow this round to here, to the tip of the cable where the connector is, and I checked the voltage here, and I could also confirm that 19 volts was available at the end of the plug. So that confirmed to me the charger was good, the charge port was good, and also the line coming up to the motherboard was good as well. So we could proceed to fault finding on the next section. Now, what I did also do at the same time was check the battery just to make sure there was no issues with the battery, and I can confirm that the battery was fine, and it was above the voltage that it should be at, which is 10.8 volts. I don't know if you can see that here. So this battery is fine, there's no issues with the battery. So let's move over to the motherboard now, and I want to show you what it is that we did and how we proceeded to find the fault. Right, so we've taken the motherboard out, and this is what it looks like. On the motherboard there are various components laid out. For example, here, this is where your CPU will be, which stands for Central Processing Unit. This here is where your RAM will be, and that stands for Random Access Memory. This chip here is called a PCH. And then you've got various other ICs and bits and bobs all around. For example, here is your headphone jack and your line out jack. Then you've got your HDMI socket, USB sockets, RJ45 sockets, VGA sockets, and there's various other bits and bobs all around the board. You've got a battery here which saves your BIOS information. So yeah, now there are various other components all around this board. There are these little ICs which are called MOSFETs, and what MOSFETs are basically little electrical switches that allow current to pass and stop it from passing. Now, it's quite common on these laptops that what will happen is either somewhere on the charging circuit or on the input power rail, you'll have a MOSFET that will short out. Okay, it's just come to end of life. It could be for a number of reasons it could happen. And if you can locate that short or that shorted component, that shorted MOSFET or IC, and if you can replace it, that usually fixes the problems. Now, other times what could happen is it could be just a capacitor somewhere on the board that has also shorted out or failed. Okay, and then other times it can be a full IC, an audio IC or a display IC, or there's various other components that it could be. But a most common issue with these laptops is either a MOSFET or a capacitor. So what you have to do as a technician is you have to come in and try and find that short, and the way we do that is with a multimeter. we take our multimeter and we start checking on different points of the board. We start checking different ICs and see if we can find something that is grounded that shouldn't be grounded. Or normally what will happen is, if there's, let's say you have there's different lines that come out of the PCH, okay, and on that line you might have a capacitor, you might have an inductor, you might have a resistor, different components. Now, if any one of those components shorts itself out, it will short out everything on the line. So it's quite easy. It's quite easy to actually find it. As soon as you find one component and you follow that line, you'll find other components as well. And then it's just a matter of trying to find out which component is the faulty one and proceeding to replace it. And that usually does the job. Now, I want you to pay attention here to a couple of parts, a couple of areas on this motherboard, because I'm going to discuss them with you under the microscope. So, the first part that I want you to pay attention to is this part here. Okay, remember this. This is the PCH. Then I want you to remember this area here. There's a coil here, or an inductor. There's a capacitor here. This is another capacitor, and this is another capacitor. Okay, so I want you to remember those parts. Now, another part that I want you to pay attention to is the model number of this motherboard. So let's get this up. It's been a bit tricky right now. Here we go. So if you have a look here, it says, if you have a look just down here, it says MBRL0200. Don't worry about the rest of the numbers. That is the model number of the motherboard. And I want you to remember this set of characters here as well. PEW71U101. Okay, so try and pay attention to those bits. And also on the other side, oh, there it is. Yeah, on the other side, if you could pay attention to this area here, where we've got one MOSFET here, one MOSFET here, we've got a resistor here, and we've got a capacitor here. I'm going to discuss these areas, this area here and the other parts on the other board, on the other side of the board with you under the microscope. So let's proceed to the microscope now, and we'll take it from there. Okay, so we've got the board under the microscope now, and I want to show you what it is that I found. So if you have a look here, just where it says PL37, just down here, just below that is a MOSFET. Okay, so remember what I was saying earlier, a MOSFET is just an electrical switch. Okay, this here is called the gate, right? These 3 pins here are called the source, and these 4 pins here are called the drain. So when voltage is applied to the gate, what will happen is it connects the source and the drain together, and it allows voltage to pass through. So what normally happens is the drain should not be shorted. It's not normally shorted. Okay, the gate, if it's not connected to if it's not connected to the output of another MOSFET like it is here, then this will normally be ground, these 3 pins, and the gate is also not shorted. So you should have a reading here, you should have a reading here, okay, but because this is not connected to ground, you should have a reading here as well, and a reading here. There should be no short here, and there should be no short here. But what happened was, when I started probing around, what I found was this was shorted, okay, this was shorted, and this was shorted as well. Now this is fine because this is connected to the ground, so this being shorted here is fine, but this here should not be shorted. Okay, so that was the first indication that something is not right here. So what I also did was I measured these capacitors in this region as well, and these were fine. These were not shorted or anything like that. This capacitor here was shorted from both ends. A capacitor is usually ground from one end, so it's like a short, and the other end is not is not grounded. So you'll have one end you'll have a reading, and the other end you'll have just like a ground signal. So this one here was showing ground from both sides. It was shorted basically. So I thought, okay, the first thing, most rational thing to do is just to remove this capacitor and see if we've removed the fault. So I proceeded to heat up this capacitor and I removed it, but the short was still present. Okay, the short was still present on the line, so that indicated that it wasn't the capacitor, the issue was somewhere else. The next thing I did was I removed this MOSFET here, okay, just to make sure that the short was not happening here. When I removed this MOSFET, what I found was that the short was still present on the line, okay, and all that left to do was remove this other MOSFET here. So I proceeded to heat up this MOSFET and I removed this MOSFET, and would you believe it, the short was still present on the line. So I removed two MOSFETs, I removed this capacitor here, and the short was still present. Now at this point I couldn't figure it out, because you can't see, just by looking at the board, you cannot see where the traces continue from this section here, because they end here and there's nothing else which reaches out. So at this point what you have to do is you have to pull out the schematics. Schematics are technical drawings and diagrams that explain where all the components connect to each other and what their readings should be and so forth. So usually you can get a board view, which is, it's like a layout that has all the locations of all the different components, and then you have a schematic which has all the technical details of each of those components. So what I'm going to do now is I'm going to load the schematic onto the screen. I'm going to show you where these components go and what we did from there. Okay, so we've got the schematic in front of us now, and what I'd like to bring to your attention is these two components here, PQ82 and PQ83. These are the two MOSFETs that we talked about earlier on, and next to these two MOSFETs are the resistor, and here is also a capacitor, PC332. Do you remember earlier on when I mentioned that I removed a capacitor? Right, so removing that capacitor had no effect. This whole line was still shorted to ground. Okay, then what I proceeded to do was to remove PQ82, which is a MOSFET, and they were still short to ground in the line, so it wasn't that MOSFET that was causing the problem. What I then proceeded to do was remove PQ83, which is another MOSFET on the same line, and I did the tests and the short was still present. So it wasn't this, it wasn't this, and it wasn't this here. Now if you have a look onto the right here, there's an IC here, PU99. Okay, it could be this IC. There may be a short inside here, and that's causing the whole line, everything on the line, to short out. Or there's some more resistors here. There's another capacitor here, PC333. Okay, that could be shorted as well, and that's why it's causing everything else on the line to short. Now, what is because there's quite a few components on this line. Okay, it's going to be time. It's going to waste a lot of time trying to take them all off and trying to figure it all out manually. There's a quicker way to find out where this short is, and what you'd normally do is you'd find the nearest inductor, or commonly referred to as a coil or a choke, and the nearest inductor is PL38, and what you do is you inject voltage into this inductor here. Okay, and what will happen is, actually I need to explain some of the science behind this first. You see, electricity likes to take the least path of resistance. So what will normally happen is, wherever you have the least resistance on any one of these components, when you inject voltage into this area here, the electricity or the current will start to accumulate at the point where you have a short, and that will show in terms of heat. So the faulty component will start to heat up, and you can get a thermal camera and you can spot that heat or that faulty component under a thermal camera, and it's a much faster way of finding it than trying to figure it out manually by taking each component off the board. So let's go back to the board now and let's locate PL38, and I'll show you what we did and how we found where the short was. Okay, so we've turned the board over, and these are the two components that were mentioned in the schematic, PL38 and PC333. PL38 is an inductor, and PC333 is a capacitor, and they're on the same line. I measured both ends and it's shorted to ground, and this here also from both ends is shorted to ground. So what I then did was, we want to find this faulty component, and remember what I said about injecting voltage and the faulty part should heat up. So what I did was I injected voltage at this point here into the inductor. I injected 1.8 volts, and it's on the voltage injection tool. It showed that it was pulling about 4 amps. And what happened is, I got the thermal camera and I started observing the board for the heat, where the heat is gathering and where it starts to heat up. And would you believe it, what I found was that this component all the way down here, do you remember I mentioned this in the beginning, the PCH, this area inside here started to heat up rapidly. Okay, now what that indicated to me was that the short is either underneath the IC where the solder balls are, maybe one of them heated up and started touching each other, or the short is within the IC itself. But either way, this was the problem area right here. So what I proceeded to do was to remove this IC. After removing this IC, I then went back and I measured all of the components that we were having issues with before, PL38 and PC33. The short had disappeared. There was no longer a short there. I then turned the board over and I went back to the area here, and PQ82, there was no short present anywhere around here. The short on this capacitor had disappeared, and the short around here on MOSFET PQ83 had also disappeared as well. So there was no longer a short anywhere on any of those components. That entire line was now unshorted. Now the thing is, you see, you gotta put everything into context, and you've got to do it in a way where you're making some money yourself and you're also saving the customer money as well. If I wanted to replace this PCH, I would probably have to buy one from eBay or from China somewhere, and you're looking at 15 to 20 pounds just for this. Then what you would also have to do is you would have to buy the stencils to reball this IC, and they'll probably cost about £5, but it's going to take 15 days to get here, 15 to 20 days to get here from China. Okay, and then you have to reball this IC, clean up all the old solder on the IC and on the board itself, reball it. Reballing it basically means attaching new solder and adhering it to the board with the heat. Now sometimes you can mess things up because it's quite a big job, that is, right? So there, it's not a very high success rate when you're doing these, unless you're very good at it and you're very professional and you've got a lot of experience in doing it. But that is not the only issue. The other thing is that if you start replacing this, it becomes a very expensive job, right? So it's easily going to go over £100 to do BGA work. Okay, so is that going to be worth it for the customer? I mean, this laptop here, I'm sure it's over 10 years old now. So, you know, the customer doesn't want to be paying over £100 to do a repair job on this when the laptop is not even worth £100. So what other options are available? That's the question. And that's what I'm going to discuss with you now. Okay, so if you open up a eBay search page and if you type in, do you remember these numbers that I mentioned in the beginning of the video? The motherboard model number MBR4L02001, PW71LA68582P. Okay, if you type in any of these reference numbers here, you'll get a whole list of second-hand used boards that will come up, ranging from £25 to £40, £50. Okay, this one here, for example, the part has been pulled from a working device and it is in very good condition. Right, this motherboard does boot into BIOS, and this guy also gives you 60 days warranty as well. Okay, so if we go back here, if you have a look, it's exactly the same board. Right, now I want to make you aware of some information here. This particular board is not only used by Acer, it is used by other manufacturers as well. So the outer casing of the laptop may be different and the manufacturer may be different, but a lot of them do use the same board. Okay, so the internals are the same. Now there's two socket types for the CPU for this board. Okay, there is the G1 socket, which is for the Intel CPUs, and there is another socket as well, I can't remember the name now, that is for mainly for the AMD CPUs. So the only thing that you need to make sure is you get the correct socket type matched up with the board. So the ones that we are using are the one on our board is the G1 socket, and the G1 socket can be kitted out with any of these chips here, Core i3 to i5 to i7 to a Celeron or a Pentium 6100, 6200 or 6300. So don't worry about if you've got let's say you've got a higher spec CPU on your board but your CPU is fine, then you can just take it off, and even if you buy a board with the lower CPU on it, you can take that CPU off and you can put your one on as long as it matches with any one of these here. Okay, so just remember, if it's an Intel CPU, you need to get the G1 socket, and if it's the AMD CPU, then you need to go with the other socket, which I can't remember the name of now. But if you do some research, you'll find it. So I think that's what we're going to go with. I'm going to order this part here for £25, and I'm going to swap the CPU out with our CPU, and we've still got this one. I think it comes with 4 megabytes of RAM. We've still got our 8 megabytes of RAM here from our old board, so we can put our CPU and our RAM in, and we've still got the original hard drive, and we should be good to go. So as I was saying, this is one way that you can save time, you can save the customer money, and you can make some money, and you're doing your bit to save the planet by putting this laptop back into the road instead of into the trash. So let's move over to the demonstration table now, and I'm going to show you. I've actually ordered this board, and I'm going to show you what it looks like. Okay, so we've got our new motherboard, which has just been delivered, and as you can see, it shares the exact same board number, MBR4L02001, PW7101, and if you have a look here, the socket is PGA988A, so it's the right socket and it's the right motherboard. It actually had an Intel CPU on here, a lower spec one. We've got an i5 on our old board, and I've removed that, and I've prepared our CPU, and I'm just going to install that now onto here. Then what we're going to do is we're going to apply some Arctic silver, which is thermal paste, and I will then proceed to attach the heatsink, the RAM and the Wi-Fi card, and it should be ready to go back into the laptop. Right, so we've reinstalled our CPU, our heatsink, our RAM and our Wi-Fi card, and the board is now ready to go back into the laptop. We've put the motherboard back into the laptop now, and we have assembled it back to its former glory. What we're going to do now is we're going to start it up and see if all our hard work has paid off. So here goes. You'll notice it says Packard Bell, and that's because we fitted the motherboard from a Packard Bell, but it's compatible with this Acer 5742 as well. Looks like it's starting up, and we're in. As you can see, it's booted up into Windows, and so far everything looks fine. Well, another job well done. I hope you learnt some stuff today regarding laptop motherboard repair, and I hope you found this video beneficial. That's all for today, and hopefully we'll see you in the next one. Bye for now, and have a nice day.